Now we are going to draw perpendicular lines in relation to a straight line R on or S in this case that goes through a point given without using the set square. Okay, it doesn't matter in this exercise whether the point we want to draw the straight line through is out of the straight line, in this case R, or on the straight line, in this case S. If we want to draw a straight line that goes through a point and is perpendicular to another one, we will have to use one of the properties of the perpendicular bisector, which is that every point on the perpendicular bisector of a line segment is the center of a circumference that goes through both the vertices of the line segment at the same time. It means that if I draw a circumference whose center is point P and that goes through point A, it will go also through point B. For example, this one. Okay, but I can also draw a circumference that goes through point Q and that goes at the same time through points A and B. For example, this one. Okay, so there is an infinite number of circumferences that go through points A and B at the same time, as long as their centers are always on the perpendicular bisector of the line segments A and B. So, how can we apply it to our exercise? What we have to do is to draw a circumference whose center is point P that meets with straight line R into 2 points. For example, this one. These points A and B, the perpendicular bisector of line segment AB will be necessarily perpendicular to line R because it's the perpendicular bisector, and will have to go through point P because point P is at the same distance from A and from B. Okay, so if we draw the perpendicular bisector of line segment AB, we will have found the solution to this exercise, a straight line that goes through point P and is perpendicular to line R. We use the compass here to draw the perpendicular bisector of this segment AB. What we don't have to do is to change the radius of both arcs. This point is point 1. If we draw a line that goes at the same time from points P and 1, that will be one of our solutions. Line T. It doesn't matter, as I said before, whether the point we want to draw the perpendicular lines through is on line R or not. We can draw a line that is perpendicular to line S and that goes to point Q if we follow the same steps that we did with point Q. We find 2 points on line R at the same distance from point Q, A and B. Okay, we do the same exercise than before, with using a center point Q, we draw an arc that meets with line S into 2 points. This one, without changing the radius, and this one, points A and B. Now we draw the perpendicular bisector of line segment AB and we will have solved our exercise. Points 1 and 2, and this line is the solution to our exercise.